Sure. Hi everyone. Thanks for joining again to the meeting. Sorry for the technical problems that we had today. So I'm happy to be here with you today to talk about Go. So we're gonna start with this session today with a little bit of history of Go. I'm gonna because this is the first session that we're gonna be doing for Golang. This is gonna be a little bit heavy on the slide side, but it's because I need to show you a few things before we can jump into the technical parts of the Golang programming language. Okay. So the agenda for today is that we're gonna be discussing about what is Go, a little bit of history of Go, why Go is different from other programming languages and things like that. Then we're gonna jump in. I'm actually going to take the risk, so to speak, to install Go in this new fresh computer. And I'm using a Mac, and I'm gonna also use Linux VM in Azure to install Go, so that you can have a different feeling of how this installation process works, so that you feel that you see that you can see that it is not something complicated, although it's not a typical next wizard that we're gonna be using. Okay. Next, we're gonna start talking about the ecosystem related to the Go programming language, especially because there are gonna be times where you would like to share some code or where you don't want to install Go in your local computer. We're gonna explore the Go playground, and then we're gonna jump in right into the Visual Studio Code and how it helps the Go extension to be better at programming with Go. Then at the end of the session, we're gonna, well, actually at the middle of the session, we're gonna be start creating our first Hello World, but this is gonna be a different typical Hello World, although it's gonna be, again, it's gonna be a few lines. I'm gonna take the time to explain to you the concepts of what I'm reading, what I'm writing, why I include in certain lines, and how do I compile and how do I run my application. So that's gonna be for today, and then at the end we're gonna have a summary and knowledge check, and all the content that I'm gonna share with you today, it's already available as a reading content. You can see the link in the chat, and you can access to this same information if you are more of the type of reading something or following along with tutorials and the things that I'm going to be doing today. You can go to that URL and continue doing what I'm going to be doing today. But again, I will welcome you to start doing things right now with me. I can give you some time to do it. We're gonna have some time for questions at the end, and if you have any problems, feel free to reach out, and we're gonna be able to help you. Ideally in this session, but if not, feel free to again go to the reading content or reach out to us later so that we can clear any questions. So let's get started. What is Go? Go comes from Google. It was developed in 2009, almost 11 years now. Almost 12 years now of this programming language, and you can see that it's quite popular right now. It is an open source project led by Robert Grismer, Rob Pike. You might see Rob Pike YouTube talks quite often. I would highly recommend you to watch talks from Rob Pike, because they are really good and informational talks. Golang was also the language of the year in 2009 and 2016 from the TOEIC index, and is the top loved languages since 2015 according to Stack Overflow. So you can see that Go popularity has been growing a lot, and especially because of some projects that have been using Golang throughout these years. I'm gonna list you a few of these projects so that you can see why Golang has been so popular throughout these years. And another thing is that Golang has many similarities with C, with the difference that Golang tries to make a programming language simpler. It's not going to be the same as C or C++, but as I was saying before, it has several similarities. Same happens to other programming languages, right? But in this case, Golang burned out of the frustration of using C. I'm not sure how many of you are here today that have been working or coding with C, but you're not gonna let me lie, but there are many things that you have to take care of it. Although it's a good programming language, low level, there are things that can get a little bit complicated. So Golang tries to improve that and tries to make things a little bit easier. So we're gonna learn a little bit what does that mean specifically throughout these sessions, and you can take a look at the content as I was saying before that I shared over the chat. So why Go is different? Go is very idiomatic in topics like source code formats. We're gonna learn that Go doesn't like, or it complains when something is not following the formatting standard, right? And we're gonna see how we can improve that, and we can be more productive as we are learning Golang, and how to avoid those warnings or that our application does not compile, right? So we're gonna learn a little bit about that in a moment. The other thing is that Go does not allow unused code, different from other programming languages where you can see that you're gonna simply get a warning. In Golang, you're gonna actually receive an compiling error. Golang, a program is not gonna compile if it has unused code. So you can't have variables declared and not use them, because Go will complain about it. Another thing is that Go says that it does not require you to have an IDE, although personally I would recommend you to use an IDE. And my choice of preference is going to be Visual Studio Code, because of the simplicity, and because it runs on Linux, Mac, and Windows, and the extension that has for Golang, it's really good. So even though Golang, or the creators of Golang, does not recommend you to, or saying that does not require you don't need to have an IDE, it is a good practice, and it's a productivity feature that we would like to have from using an IDE. So I would recommend you using that. The other thing that is different from other programming languages is that Golang prefers to use standard libraries over frameworks. It doesn't mean that the frameworks in Golang does not exist, but Golang, the creators of Golang were thinking about the standard libraries, saying that this is everything that you're gonna need. This is the philosophy that we want to continue having. This is we would like to continue having simplicity and not overcomplicate things. You can create your own things from these standard libraries, but the idea with Golang is that you use those standard libraries instead of frameworks. I have my opinions on that, but that's the philosophy of the Golang creators, and you're gonna learn why that is a good idea as you continue learning in your journey learning for Golang. The other thing that is different is that concurrent programming it's quite different in Golang. Actually, when you approach this topic in Golang, I would recommend you to forget about what you know about concurrency in general from other programming languages, and try to start learning concurrency from this perspective, because it is really powerful. And sometimes we have problems. I especially have problems trying to bring all the knowledge that I have to Golang when talking about concurrency, right? The other thing is that it is pretty idiomatic on the error handling. Go does not have exceptions. We're gonna learn in future sessions, and again in the reading module, that I share with you in the link that you have over the chat, there's a section that explains error handling in more detail, but you're going to learn that it's different. It's very idiomatic. There are certain um, uh, signatures and standards and format, coding format that you have to follow. That is actually a good thing, because when you read others' code, you can see that they are following the same standard. You can understand others programming or others programs very easily because of this standard, right? So there are a few things that are really, really good with Golang that I really like, and those things are the philosophy of keeping a standard over how you write the code. Okay. So let me give you a few examples of things that has been written in Go. Docker is written in Go. Kubernetes, who knows Kubernetes, right? Or at least you have heard about Kubernetes. It's written in Go. Terraform as well. Netflix uses Go. Dropbox, SoundCloud, Uber, and Drone. So, but I guess that personally, on the recent years, I've been using more Docker, Kubernetes, and Terraform. So I'm really happy that Golang has been increasing in popularity, because these are pretty good examples of how a programming language can be used to write awesome tools like Terraform, Kubernetes, and Docker, right? So I guess that everyone now is aware, at least at some portion, of these three technologies, and it's good to know that this is really in Go. And perhaps that's the reason why Go popularity has increased over the years, and it continues to do so over and over every year, right? However, there are a few things that Golang would like you to know from the principles perspective. That is that the idea or the philosophy or the principles of Golang is that they would like to, or the Golang language would like to keep things small and simple. As I was saying before, concurrency, it's a pretty big topic in Golang, and it is a first citizen in Go. So again, this is the first session. This is the first time perhaps that you're hearing about more details about Golang, and you're going to learn how does that look like. But concurrency is a first citizen in Golang, and we're gonna learn why as we continue studying that part. Compilation and execution should be fast, as I was saying before, because you don't have repeated code. You don't have unused code. You are the code that you have. It's the code that you're actually gonna use. You don't have to wait for a long time for this compilation and execution to finish, because ideally you're not gonna be using a lot of frameworks, a lot of libraries. Most of the standard libraries are already have already what you need. So the idea is that you don't go outside to look for something that you might not need. So that's the basic idea. Something that is really important is that casting has to be explicit. Otherwise, it's not going to compile. We're going to learn next week about this specifically when we discuss about types in Golang, where you cannot cast implicit one type to another type, because that will give you some error. You have to be really explicit, and that helps you when you're reading others' code as well, right? So the other set of principles is that, as I was saying before, unused code is not a warning. This is very different with other programming languages, because in other programming languages, what you will have is that code when you're compiling, you simply are gonna get a warning. But in this case, Go prefers to not let you continue instead of leaving, for example, reserving, allocating memory that you're not gonna use anyway, right? So the idea of Golang is to break the build and give you the details of what you should be using, right? We're gonna experience that in a moment. It has official formatting to maintain consistency. This is actually a pretty good thing. And when we're using an IDE, in VS Code that comes by default. So that's a pretty good thing if you are using an IDE. As I was saying before, it's not a good friend of frameworks. And as I was saying before, it doesn't mean that you don't have frameworks in Golang, but Golang prefers not to use them. So it's up to you if you would like to use them. The idea of Golang is to keep backward to continue being backwards compatible. So you can rest assured that what you have in the current version right now, which the latest one it's 1.16. If you have something in previous version, it should at least compile and should work right. So the idea of Golang is to, or the philosophy or the principles is that everything that they do should be backwards compatible. And lastly, but not least, is that the project is open source. It's led by Google, but it's open source. It's an open source project, and you can contribute to that. You can see the progress that as a community we've been doing and we've been receiving. So that's basically the key principles of Go. So that's everything that I had for you for the history and explain to you a little bit of why Go is so popular, what are the key principles, and I know that that's just what I just shared with you is just theory, and you can find that in the links in Google and in every other book. But I wanted to make sure that you have this in your mind, because when we are gonna be using Go, this will come again and again and again and again, and sooner you're gonna speak this philosophy and these principles if you continue in your learning journey. Okay. So the first thing that we're gonna be doing is to install Go. So I'm gonna be brave enough to install Go, and the idea is that I would like to share with you um, how it looks like the first encounter with Go. So for that, I'm gonna be installing things on Mac. So as you can see, it is pretty easy. If you have a Mac, you simply brew update, brew install Go, and that's it. Go will install on user local Go, and that user local Go bin, it's gonna be added to the path. So that's gonna be what everything you're gonna be needed. We're gonna continue discussing. We're gonna continue discussing about these particularities about Go in a Mac environment. Then I'm gonna share with you the examples of how to installing this on a Linux environment, and I'm gonna simply run these commands. Okay, so we're just simply download the installer, you untar that installer, you export that path. Basically, what you have here automatically, you have to do it manually in Linux. You then include or reload the environment variables, and then you're gonna be able to see everything the same experience as with a Mac user. So let me show you how this looks like in my environment. Okay, so I'm gonna go here. This is my environment. This is where I have right now, and because I already did something like this, install Go in my environment, because I didn't want to install this again. You can see that it's already installed and up to date. I don't want to continue doing that. Okay, so I created a new user in my computer so that you can see the pain points that you perhaps are gonna have when you're installing Go. Because you might think that, as with other programming languages, that's gonna be it, right? That's gonna be everything that you're gonna be needed, and that's it, right? But in the case of Golang, that's not the case. There are a few things that we need to do before we continue. So the first thing is that to confirm that I have everything running, I'm gonna do this Go version, and that's it. You can see that the 1.16 version is up and running. Okay, so I'm gonna actually go here into my a Linux VM, and I'm gonna use this. It's gonna be this one. So let's see, we enter here, and you can see that I'm in a Linux environment, right? I have here everything, so I'm gonna go here and start including in doing those things, these steps, right? So I'm gonna actually exit here the from the presentation mode, and then I'm gonna go here and run those commands. So the first thing that we need to do is to copy this command, which is gonna be basically download the installer, and we wait for a moment here, then we untar this, and we simply run this command here. Well, let's see, I have to do it this with sudo permissions. Okay, got it. Then notice that now I have to do something like this, add that environment or that URL to the path environment, because as you can see here, it's going to be user local go. We have here this installation. It's basically what you have in the installer, right? So you can see here the binary, it has the go installer. So that's gonna let me to do something like this, right? So if I do, well, perhaps this is not gonna be needed if I include this. If I want to make that persistent, I have to include that in this file. So if I do something like this, and I'll go to the end of the file, you can see here that there are a few things here. And if I include this, if I close this, and I do something like source, this is gonna be now persistent. Okay, so if I do something like this, echo path, you can see that the folder is already there. Why do I need this? Because if I do something like this, I would like to see the command, right? So I would like to see that Go is up and running. So that's it. That's how easy is to install Go in Mac and Linux. Hopefully, I haven't done that fast for you to follow along, but that's basically the idea of installing Go in a Mac and a Linux environment. So there are a few things that I would like to discuss. Once you have this installed, there are a few things that you need to keep in mind. How Golang organize the code and how you're gonna have to organize your code. This is really important, and I would like you to pay as much attention to this point, because otherwise you're gonna have a few problems trying to write applications the way that you are used to write them in other programming languages. This is very idiomatic in Go. Although the process has now been improving, I think that for starters and for someone that is starting with Go, following this simple process, it's gonna help you a lot, and it's gonna help you to at least feel that everything is working, right? So what I'm trying to say is that Go works under the concept of workspaces. And a workspace is simply where the application source code lives. It's a folder in your workstation. All projects share the same workspace. This is where Golang differs from other languages, right? Because you have one workspace that you have to configure for all of the projects that you're going to be reading in your workstation. By default, that workspace is going to be at your home path /go. So all the source code that you're going to have has to be included in that folder. Okay. Since Go 1.11, there's an improvement, but let's keep it simple for now, because well, in case you're curious, that's going to be Go modules, but we're going to cover that in future sessions, perhaps. And again, that's already included in the link that I shared with you initially. So even though there's a better way, let's keep it this way so that it's gonna be easy to understand, and at least we're gonna make sure that this is gonna work, right? So the first thing is that again, by default, you're gonna have here in your home Go path, but you can have a different location if you want to. However, this is not going to be true that you can have multiple locations, right? Because all the projects are going to share the same workspace. And because we wouldn't like to complicate things, we're going to just keep things simple and use one workspace for everything. But in case you would like to have another path for your workstation, you can simply set that in the Go path environment variable, and again, added that to the profile to make that persistent, and you can get that information from running that command. So, for example, if I do something like this, go env, I can see that the Go path it's going to be home Azure Go. If I exit the VM and if I run this in my local computer, go env, go env, you can see that the Go path, it's gonna be basically here, it's gonna be included here. It's gonna be users, my user / go. So if I do something like this, Go path, I should be able to see that, but because I don't have that, I have to include that in the profile, right? So I'm gonna be doing what I just did initially, right? So I'm gonna be doing something like this. I'm gonna be, sorry, let's do something that we've been added. Well, I remember now. We were doing that in the in the Linux environment, right? So in my case, because I have another profile here, let's do here. In this case, it's gonna be this, and I'm gonna include here the export path where I would like to see that workspace running, right? So you can see here all the information for my environment in a Mac environment. So I'm gonna simply do something like this, go path. It's gonna be this home /go in lowercase. Okay, so I'm gonna export this, and I'm gonna do well, actually, let's do something like this, but sorry, my keyword is not okay. I do source, so if I do something like this, okay, now I have to make sure that that location exists, right? And if I go something like this, like cd go path, no such file or directory, because that does not exist, right? So I'm gonna create that, go home, go, and if I do something like this, okay, I can see that I'm in my workspace right now. So again, it doesn't matter where you are gonna be having your workspace, you have to have at least one. So it's pretty important that you have that, right? So by default, that's gonna be here. As I was saying before, go env, go path, it's gonna be here in my user, okay? So once I have that in place, I can continue with my application. But before I do that, there are gonna be a few things that we're gonna have in this directory. Right now, because I'm starting from scratch, I don't have anything else. But when you're gonna be adding projects, adding reference to other things, there are gonna be 3 folders that you have to keep in mind. So in your workspace, you'll find the following folders. You'll have the bin, source, and package folders. The bin folder is going to contain executables from applications. That's going to be tooling, that's going to be things that you might going to be needed in order for libraries or extensions or things like that, things that you would like to install in your workstation as an executable from a Golang application. The SRC or the source folder includes all the application source code that we're going to be included. The package the PKG folder contains compiled versions of the available libraries. This includes the external libraries that we're going to be having for our programs. Okay, so how does that look like in an environment that is not fresh like the one that I have right now? It's going to look something like this. So you're going to have the bin folder with two executables here. For example, hello, cool app. Those are going to be programs compiled in Go. Those are going to be executables. If you're on Windows, those are going to be hello.x. If you are in Linux or in Mac, those does not require to have an extension, but it's going to be an executable. The package or PKG, it's going to be the source code or the packages, the packages that you're going to have from other libraries. In this case, I'm using a library from GitHub called Gorilla, and you can see that the extension of that file it's gonna be ending with A. So in this case, it's gonna be mux.a, and that's how it goes as the standard, right? That's gonna be the standard for a library in Go. Whereas you can see here that in my source code, I'm gonna have this github.com Golang example. That's gonna be the project, so to speak. And you can see here that we have a folder here and we have a hello.go. Every file that ends with go, it's gonna be the source code for a Golang programming. Okay, so keep that in mind. So that's basically how you're gonna have to organize your code, and that's basically what we're gonna be doing in a moment to create our first application. But before we dive into this, let me show you how to explore how to use or how to interact with Go when you don't have or you don't want to install something here, right? So we're gonna go to this URL playgolang.org and we're gonna keep a look at that. So let's go to this URL. Let me open a new tab here. So we're gonna see here playgolang.org, and you can see here that this is the Go playground. So I don't have to have anything installed here. I can simply run this. It's gonna execute something in a server. I don't know where. I don't care really. But this is basically as if you were running something externally that has Go installed. So if I do something like this, hello reactor, and I do something like, for example, like this, or I include more spaces, I can simply run this format, and that's gonna throw a warning, right? It's gonna throw a warning that I have to I don't have this in place here. So I have to make sure that I have here this. And if I format this, that's gonna, again, apply the format, right? I was kind of going to the extreme that adding an error here. So if I do something like this, or if I do something like this, I'm not sure what type of developer you are. If you are this type or the other type where you would like to have the braces, I'm sorry to let you know that if you are in this case a programmer like this, Golang does not follow that standard, right? So Golang follow this standard, and if you format this, it's gonna format the code in this way. So if I run this again, this is pretty good for practice purposes. And if you would like to share some snippet with someone externally and you don't want to share all the source code when you are presenting a solution, when you are presenting a problem, you can use this, right? So you can share this URL. This is going to be a unique URL that is going to include this code, and anyone with the link is going to be able to see that code, run it, and so on and so forth, right? So this is pretty convenient when you would like to share things with someone externally, and when you don't want to install Go and you simply want to give it a try to something locally, and you don't have a Golang install. All right, so even though this is good, and this is something that it's gonna help you, it has a few limitations, right? So the few limitations that it has is that keyword inputs are not supported, random numbers are deterministic, and time is constant. You're gonna always have the same time over and over again. So those are gonna be the limitations that you have, but again, that feels too much like if you were developing in a notepad or something like that, right? So I wouldn't recommend you to use this if you want to go be serious about programming in Go. So for a better option, we have VS Code, which is something that I will recommend you to do. So the first thing is that you need to do is to install VS Code and install the Go extension, the one that says Go Team at Google. And the good thing about this extension is that formats the code automatically. So I already have downloaded the VS Code installer here. So I'm gonna run it here. I'm gonna show you the process of, you can see that this is something really fresh, right? I downloaded that a few minutes ago. You can see that this is a fresh install. Right, now that you have VS Code here, you can see that it is pretty simple and pretty easy to have this install and up and running. That's pretty much the reason why I like to use VS Code. And the second thing is that when you go here to the extensions, you can see simply type Go and this one, right? Go Team at Google, right? So we're gonna install this extension. We install it, and I'm gonna actually quit this, and I'm gonna open it again. And you can see here that this has been installed, and I have everything here that I need, right? So now that I want to do that, now I would like to start creating something, right? But remember what I just said, right? You need to install, or you need to start over here with the workspace that we're gonna be using. So in this case, I'm gonna use this. It's gonna be my user, and it's gonna be this folder, and this is gonna be my workspace, all right? So this is gonna be the content that we have. So I'm gonna have here a source directory. Notice that I'm having everything here from scratch so that you can follow along this in your clean environment. So I'm gonna create a new project, which is gonna be Hello World. And I'm gonna create an application. Something that is really important here is that notice that I don't have, I have created a file that is called main Go, and now VS Code recognizes this as a Go application, right? There are a few things that I would like to discuss. It doesn't matter really what name you put here into the file. I can here put everything and it's gonna work. It doesn't really matter, right? If I include another, for example, another Go file, in reality, Go, it's gonna take all of these files as part of one application. We're gonna talk about this later, how you can segment your code in an upcoming session. But in this case, it doesn't really matter what you have here as the name. But it is a good practice to follow the standards that we already have. And the idea is that you are gonna have for your running application for the code that you're gonna be using main.go. So follow this standard for now. and that's gonna be it for now. Okay, so I have already in my in the slides that now I would like to start with the hello world. But as I was saying before, this is gonna be quite different, right? So um, as if you remember well from the playground, what we have is that we have a portion of code that I didn't explain because I wanted to take the time to do this. So the first thing that you need to do is to create a package or include this line, which is basically you're gonna say in package main, this is gonna be the name of the package that you're gonna be creating. If you're running an application that needs to be executable, that needs to run something and do something, you have to include that main. The other, that package. The other thing that you need to do is to create a function called main with no arguments. Okay. Sorry, I have here this this a new keyword here that I'm struggling. Okay, this is it. This is it. Okay. So in this case, this is like the simple skeleton that you're gonna have to have for your application. You can have this, and that's gonna be everything that you're gonna be needed. Okay. So the first thing that you need to do is again create the package, create the function, the first function that you're gonna be needed, that you're gonna be using, and that's it. Okay. Remember again what I just told you, right? You have to create this in the in the in the proper directory, in the proper folder. Otherwise, you're gonna have problems when doing something like that. So this is what I like about VS Code, because I would like to do something like this, print line, and because I already know that this is gonna be the name of the function from a standard library, I simply include something like this. And notice here, right? I have 5 lines. When I save this file, and if the extension is working correctly, which in my case for some reason is not recognizing that part, it does recognize that environment, but I should be able to write something here, hello world, and when I save it here, I have to include also the package that I'm gonna be using for this, right? So it's gonna be the package that I would like to use, and this is gonna be the function that I would like to use. So VS Code also has a terminal integrated here. So if I go here and I clear this, and I go to hello world, let's see, actually go here, cd hello world, and if I do something like go run, go, I should be able to see this. Oh, okay, I see my error now. So if I do something like this, print line, and if I, sorry, fmt, and if I do again something like this, I should be able to see hello world. Okay, so this is pretty much what I, or hello world, and this is what we would like to see. So what happened here? We're referencing a number, we're doing a few things here. So the first thing is that we're gonna be creating our first application that's gonna be from the package main, and this is a special package, so to speak, because the idea of this package is that you have an application that is gonna be executable, something that is gonna be doing something. If you don't want this to do something, but it's going to be a library, you can have the name that you would like to have here. Doesn't really matter. But no, you have to know the difference between this and another library, right? So if you have package main, it's going to be an executable, and if you have a different name than that main, it's going to be a library. That's As simple as that. That's the standard in Go. If the other thing is that when you're creating a main application, you have to have a main function as well. This is gonna be like the bootstrap or function or the starting process where everything your application is gonna start running. You have here the references for the packages that you're gonna be using, and this is gonna be the print line package. So notice something. I think that I didn't. This is what I like about Golang because it is open source. You can actually go here to Golang FMT print line, and if you go here to the package library, you can see here the overview of this library, and you can see the functions that you have, and you can see actually the code. You can see here print line that is gonna be here, and you can see the signature of that function. You can see the example, and you can actually go to the source code in GitHub. So you can see the details of this. This is open source, and this is what I really like about Golang, that has everything here already documented, and it's pretty easy to follow along, right? So everything that you have here, it's gonna be included in that documentation site. So the last thing that I would like to do is, or to explain to you, is that there are a few things that we did here transparently, right? So we did basically go run main Go, and that compile and run the application. But if I just want to compile the application, I can simply do main Go, do something like this, and you can see that it's not going to do anything, right? But if you pay close attention to this, it created an executable here. So if I do something like this, you can see the difference here, that it's an executable. So if I do something like this, main, it's gonna run the application. I can take that executable, that binary, move that to another server, to another location, and that's gonna work. I don't have to have Go install in that application because that's gonna be an executable. That's not gonna be the source code. That's actually something pretty good about Golang. So those are gonna be the commands, that the two commands that I would like to introduce you this time, at least for now, as your first encounter with Golang. So with that in mind, I guess that we can close this with just a few things that I would like to add here. Is that what's the command for executing and compiling Go apps? If you remember this, we already talked about this. Go build, it does something that it simply creates the binary, right? Go install, it is gonna be something that is gonna be create the libraries, and go compile, that actually does not exist, right? If we do something like go compile, main Go, that does not exist, right? So the correct answer is gonna be the second one, go run. Now, for another question is, where should you place your project files on your workstation? Anywhere I want, at the root file system, or at the workspace directory. Anywhere I want, that works for other programming languages. At the root of the file system, that's a tricky question, that might be, but in reality, the answer is gonna be at the workspace directory. The workspace directory could be anywhere, but you have to specify that, and you have to specify in the Go path environment, a variable, right? So that's it. That's everything that I had for you. As a summary, all projects share the same workspace. Just keep that in mind, and you're gonna be having less problems when you're gonna be programming in Golang. By default, that location is located at that home./go. You have to place your code at go path source directory and know your command, right? Go build, go run. VS Code, it's gonna help you to increase productivity because it's gonna have an IntelliSense, as you can see that I was able to write the package main, the func main, and as we continue adding more complex things, you're gonna see really the benefit of using an IDE like VS Code. So that's everything that I have for you today. If you have any questions, I think that we have some time for those.
Thank you, Christian. Thank you so much. We did have, I think we have one questions from the here asking how do we update to different versions Linux? Let's say 1.18. I don't know if you can see this question in chat.
Yeah, I can see it. So it is, as I was saying before, in Linux, it is really something really easy because it's simply a binary that you install or that you download in your workstation or in the workstation. So you simply will have to upgrade. You have to download the new version 1.18, locate that or put that into this location bin or this local bin. I mean, that could be any place again, right? That could be another location if you want to. As long as this location is going to be included in the path, you can have that anywhere. So you simply replace that binary file with the new version, and that's going to be it. At least in this way of installing Linux, right? If you're going to be doing in macOS, you simply do a brew upgrade code, and that's going to download and install the latest version on your workstation.
Thank you, Christian.